All right, we're moving forward with chapter 2 here, moving right along, solving some equations. So the next thing we're going to do is use all those solving skills to solve what's called a literal equation. And what that means is I just want you to reorganize the equation that you're given. So when we take a look at this equation here, the number of pizzas, the number of sandwiches, models the problem, then we're going to solve it. How many sandwiches can buy? Buy 3 pizzas, 6 pizzas, and going on from there. So since you're going to do a repeated operation, right, at some point I need to plug in 3, and at some point I need to plug in 6. So these are the things that we're after. So it'd be a whole lot easier if we complete this first task, which is to solve the equation for y. So I'm going to put this down here. 10x plus 5y equals 80. Well, I'm going to get rid of the 10x. So I have 5y equals negative 10x plus 80. And then I'm going to divide everything by 5. So my first task is just to write it as y equals negative 2x, all right, and 5 goes into 8 one time. Okay, so that would be 30 left over, so 16. So it makes it a little bit easier to deal with. All right, well, y is the number of sandwiches. That's how many sandwiches we can get if I buy 3 pizzas. So that means 3 is x. So I'm going to do this. Y equals negative 2. I'm going to buy 3 plus 16. So y equals negative 6 plus 16. So that means if I buy 3 pizzas, I can still get 10 sandwiches. Sounds like a good lunch. Let's start over. Y equals negative 2x plus 16. Well, what if I want to get 6 pizzas? That means y equals negative 2 times 6 plus 16. Y equals negative 12 plus 16. Well, that means I can only get 4 sandwiches, or as I like to say, sandwiches. All right, if we get 6 pizzas. Okay. So the upfront work makes doing this, right, solving for y, means solving the other 2 things a lot easier because I didn't have to rearrange the equation each and every time. Okay, so that's why we work with literal equations. You're going to do a whole bunch of it, especially when you get to physics. We're going to work and do some experiments, and often you're going to calculate time over and over and over again as you repeat something, or you're going to calculate the distance over and over again. So you might rearrange the equations. Okay, so we're going to try that again. No context to this one, so it's not as cool as pizzas and sandwiches, but we'll give it a try. So the thing we're after is solving for m. So 4 equals 2m minus 5n. Solving for m, so let's get rid of the n. So I'm going to add 5n. I'm going to flip it around. 2m equals 4 plus 5n, and then divide it by 2. So m equals 2 plus 5 halves n. All right, well, let's try it out. So this is my equation, and now we're going to do this when n is negative 2. So n equals negative 2. Let's plug it in. M equals 2 plus 5 halves times negative 2. Right, well, keep in mind that this is over 1, and the 2's cancel out by division, so we get negative 1 out of this. So I get 2 plus negative 5. That means m turns out to be negative 3. So that means I plugged in negative 2, and I got negative 3. The next one is 0. So m equals 2 plus 5 halves times 0. Well, you guys know what's going to happen here. This is multiplying by 0, so it goes away. So m equals 2. So it means I plugged in 0, and I got 2. So we can start to build some ordered pairs this way as well. And then the last one, we're supposed to plug in 2. So if n equals 2, m equals 2 plus 5 over 2 times 2. Again, remember this is over 1. So I would have 10 divided by 2, which is 5, or the 2's just divide each other out, plus 2. Well, that means m equals 7. Okay, so 2 gave me 7. So we can always start to build a domain and a range, because I know that's one way we talk about these. In middle school, often they use input and output. So domain and range is how we'll use that as well. All right, so all of those previous problems, we were dealing with solving something, and then we were trying to do something afterwards, where literal equations, right, we might only ask you to rearrange the equation. So what equation do you get when you solve ax minus bx equals c if we're solving for x? Wow, this is a tough one, guys. It really is. Because the thing you're trying to get alone, you have 2 of them. So what I need you to think about is, in your prior knowledge, is what would you say the greatest common factor of, let's say, 22 and 2, right? Let's not use those. Let's use 6 and 8. What's the greatest common factor? Well, the greatest common factor, I hope you realize they're both divisible by 2. So if I did this, I could make it 3 and 4. So that's kind of the idea of what we're going to work with here if I were to actually divide it out. Because ax and bx, they both have an x. So what I'm going to do is I want to take that x out and put it out in front, kind of the way I modeled with this 2 over here. So if I divide by x for each of these terms, I have a minus b, and it equals c. Right, well, now that they're being multiplied, right, x is being multiplied by this a minus b, but I want x all by itself. So what's the opposite of multiplying? It's dividing. So divide it by this a minus b. So x equals c over a minus b. Okay, that's a tough one, right? And the key was way back here in the green highlighter, if you have 2 of the thing you're trying to solve for, we have to start thinking this involves the greatest common factor at some point. Okay, so we want that to kind of end up in our brain. All right, circumference of a circle. So that means we're going to use c equals 2 pi r at some point, right? So I gave this little chart, right? I'm not in the business of trying to have you memorize every single thing we got here. Okay, what's the radius of the circle with a circumference of 64 feet? Okay, so they told us that what the radius is going to be, right? So without saying so, I would really like if we could rewrite this equation because we're trying to find out what the radius is. So I want to find out what this equation looks like if the radius r is all by itself. So how do I get rid of multiplying by 2 pi divided by 2 pi? Right? So the radius is going to be whatever the circumference is divided by 2 pi. Well, they actually told us the circumference, right? 64. So let's go one more step. 64 divided by 2 pi. Well, 64 divided by 2 is 32 over pi. And I'm going to leave it just like that. It says the nearest tenth. Okay, that would just be some calculator work. I'm not overly worried about it. Okay, if you want to go ahead and get it, please do. Okay, so that's a situation where it'd be a lot easier if I could rearrange it first and then I just have to plug it in. We talked about using some of this in science class, and here's one for your biology study. The monarch butterfly, all right, so that's this guy here, is the only one that migrates north annually and south. Okay, the distance that a particular group of monarch butterflies travels is shown. All right, so what do we have here? 1,700 miles. It takes a typical butterfly about 120 days to make this trip, right? Travel one way. What's the average rate in which the butterfly travels in miles per day? Right, so we need a distance formula, right? Remember that? Distance equals the rate times time. Okay, so what's our distance? Our distance is 1,700, and what's the rate? We don't know. What's the time? 120 days. All right, so we see what's going to happen here. How does this tie back to literal equations? Is if I were to rearrange this equation here and say that I'm solving for the rate, that's the thing I don't know. If I just divide by t right now, I would have the distance divided by time will give me the rate. Okay? So when it's an application like this one, we can do it early or we can do it late. It doesn't matter. We just need to solve for the final answer. So the rate is 1,700 divided by 120. So we'll find out how many miles per day that little butterfly is going to go. Okay, so make sure you get that final calculation. All right, I do have a couple here that I do want you to try. Okay, even though it's kind of brand new for you. So 1, 2, 3. So as I look back at your notes, I just want to see that you have tried these 3 out, so I know that you were able to do something with it. Okay, homework. All right, eventually, after we do some things in class to make sure you're okay, then we're going to do some highlighted problems down here. So if you are super duper feeling really, really good about this stuff, if you want to give some of those a try, I wouldn't do all of them in case there's something that you need some help with and maybe you don't realize it yet, but that's where we're at. All right, see you in class.